Who's starting today?
Huh?
Yeah, it'll actually be me, Nick Zeranski. I'll be the one
Nick.
that's kicking it off. Yep.
All right, Nick, then. Just kidding.
All right, let me just start sharing. Hopefully everybody can see the screen.
You're perfect.
All right. So if we're good to go, really just wanted to thank everybody for their time. So we're going to be going over just really concentrating on using Cisco Secure Workload and Duo as part of the Zero Trust strategy. And real quick, I'm just going to go over just some of the other parts of Cisco's Zero Trust strategy, and then I'll kick it over to Mike and Jem for a deep dive into specifically Secure Workload and Duo. I guess that was the agenda that I really should have done. All right, so I think everybody knows that effective security, we really need to see everything, right? That was part of a lot of the initiatives with, the CDM project, right? You still have it in, the sys controls, everything. We need to understand everything that's on our network, get visibility into all the hosts, and really have an understanding of what's normal in order to have effective security. And you can tie that into, the entire Zero Trust strategy, which really I always look at it as it's really just the privilege of, least privilege access, right? We're trying to lock down everything, segment everything to, only give the appropriate rights at the appropriate time to the appropriate users and devices. So the CISA model really we've kind of seen that as taking more of a precedence within kind of the federal industry right now. That seems to be what most people are kind of following through with the different pillars of identity, device, network, application, and data. And Cisco kind of had our own approach where we talked about workplace, which when Cisco talks about the workplace, we're really looking at your actual offices, your wired and wireless devices that are connecting. How do we secure everything that's really within a building? We have the workforce, which is we're looking for how do we secure our users and devices and take those users and devices even when they're off network, and how do we still provide that same security to those users and devices regardless of if they're at a workplace or not. And then the workload section, where we're talking really about how do we deal with all of our applications across all of our data centers, our cloud, anywhere where it resides, how do we provide the security to those segments? So really, we're going to kind of do that deep dive into the workforce and workload, but just wanted to touch on some of the other products that we offer to take across everything. And just the overall mapping. So this slide really just kind of shows the overall mapping. When we talk about our workforce, we're really kind of taking that identity and devices pillar. The workplace, we're really looking at really the network pillar. And in this part of the workload, we're touching on both the applications and the data pillar according to the CISA model. So for workforce, we really start talking about Duo, right? Duo is an MFA product, but it supports the push, it supports one-time passwords, it supports YubiKeys, lets people enroll, really quick and easy to integrate with all applications. We can also identify whether it's a corporate-owned device, a BYOD device, take a look at the security posture on device, block access to applications to if we decide that the device health is not up to date, or we tie it into your MDM or your anti-malware solution. And if a device gets malware on it, we can prevent it from accessing a SaaS solution, right? Or your email solution or anything that's maybe even not even on the network, right? We can take a look at that device, and if it's not meeting our security policy, or if it has a change to the security policy, we can prevent it from accessing something even while it's no longer on the network. So that's part of that trusted access, right? Where not only are we doing the risk-based authentication, but then we're also going to start continuing to look at that device trust, what our policy is, and we can build the policy based on users, based on devices, based on applications, or a combination of all of that. When we move to the workplace protection, we're really talking about, one, let's get an idea of all the traffic. So we like to take NetFlow data, and we'll take NetFlow data from all of the switches, whether it's your NAT devices, your load balancers, your firewalls, AWS VPC logs, right? We can take all that net flow and logging information, and now we can start building a communication path of here's everything that talks together, right? Here's what client and server is talking. Did it go through a NAT translation? What service is being used? Or what user is actually the one that's using that process or kicked off that process? What application is being used? We can tell the process hash, right? So what's the, not only what user kicked off the process, but what was the actual process hash that's responsible for that communication flow? And we can take all of that information, you can use it to start building a security policy. And we can also look for, user and entity, behavior analysis, right? So now we start looking at layering in some machine learning and looking at, anomaly detection, right? Doing some trust modeling so that we understand what normal is in the environment. It's one of the biggest challenges that we see is, just understanding what is the normal traffic in our environment, right? And it's hard to understand what normal is and get a baseline because we never know, are we baselining something malicious? So that's why, being able to use that net flow and take a look at here's the communication path and also understand what, malicious traffic looks like and being able to monitor all that and then give you a complete picture of visibility of here is the traffic path that we're having. Here's what's malicious. Here's what's not malicious. Here's some of the threats we see, whether it's, recon or someone's exploiting a host, or maybe we have someone doing some data exfiltration or data hoarding. But being able to look all that from a behavioral analysis of the traffic, it's one of the things that we see really on the workplace and really helps to start being able to build a more in-depth security policy. And of course, any time that we're talking about the actual on-premise and your network pillar or the workplace pillar, we have to talk about Cisco ISE, which is going to tell you who's connected to my network, what time did they connect, what type of device are they on, right? Where are they at on my network? How are they connected to the network? What is the health of it, right? Tie it into, again, the anti-malware solutions and see, are there any threats on the device? And if so, should we change the access based on that? And tie it into, vulnerability scoring, right? Whether you're using, Qualys or Rapid7 or Tenable, let's tie all those tools together. So now that you have that complete picture and you can really secure the environment and make decisions based on the actual context of the user, the device, the network, and the health of it. Another part of the network pillar would be, using whether it's a firewall as a service like Cisco Umbrella, or whether it's an on-prem like Firepower, but being able to, really have a firewall IPS protection and protect that edge of the network, right? So although we're talking about zero trust, right? When we still have an edge of the network that we still have to protect, we still have to be looking for threats, tie it into all those tools and do as much as we can to protect these devices. And then moving on to the workload piece and really kind of that application and data pillar. That's where we call it Cisco Titration or secure workload is the kind of the new name for it. But secure workload, what it really is going to do is allow you to understand, what processes are running within your data center. And when I'm using the term data center, that whether it's a cloud data center, whether it's a public data center, a private data center, or whether it's, just your actual data center that's sitting on-prem, right? It covers all those use cases. But to understand, what processes are running, what are they talking to? What's my software inventory? What vulnerabilities do I have based on that? And then really start to help you build out an allow list model of what applications are talking to what and how are those applications communicating, so that then we can take that application policy discovery or application dependency mapping and really start building that policy so that you can move from, that our typical, deny model, right, where we're allowing all traffic and then just, denying just, the things that we deem malicious, to now let's block all traffic except for the actual communication paths that we need for our applications and services to run. And being able to model that and then be able to push that into, our policies and get that, consistent across, all those data centers and cloud environments. that's really key to really securing the application and your data. And then I'm going to kick it over to Mike Delaguardia, who'll be able to do a little bit deeper dive into Cisco Secure Workload and give some more information on that and a little bit of a demo.
Awesome, Nick. Can you hear me okay? This is Mike.
Yep, I got you, Mike.
So hey, everybody. My name is Mike Delaguardia. I'm a solutions architect within the Cisco Security Business Unit. And as Nick mentioned, I'm going to walk you guys through a little bit of a deeper dive on Cisco Secure Workload. And to do that, I'm going to share my screen here and just let me know when you guys can see it. If anybody wouldn't mind just speaking up and say, hey, yep, we see it.
Looking good.
Got it.
Excellent, great. So Nick, thanks for that tee off. Obviously we're going to go a little bit deeper with Secure Workload and Duo today. I'm going to represent the Secure Workload side, and then I'm going to hand it over to my friend Jim to get deeper with the Duo side of the house. So for these next 20, 25, maybe 30 minutes, let's just get into Secure Workload. I'm going to tell you a little bit about it more in depth and show you, an actual product UI walkthrough and kind of explain the key use cases. So as Nick mentioned, Secure Workload is really, aligning itself towards helping customers provide additional security closer to the applications and data side of the house. And so what that means is this platform, right? And I'm going to walk you through it here in a minute. It's really going to be close to your what we call the workloads, and those workloads are anything that we would define as, traditional virtual machine, bare metal, container, cloud host, something that might run in traditional EC2 environments or Azure environments. And so the idea is, where you have the critical infrastructure, the applications themselves and all the data that is extremely valuable, that might be in those traditional data center or cloud type facilities. This is where Secure Workload naturally will live. And the goal of the platform is to frankly help you shrink your attack vectors to your adversaries, right? That might be shrinking your software attack vectors, shrinking your network attack vectors. And what Secure Workload today, it used to be referred to as Tetration Analytics because the platform itself has kind of morphed over time from being just really, frankly, a data analytics and visibility solution. And what's happened over these years is our customers have really taken the data that the system kind of collects and processes and really asked Cisco to kind of take the use cases and morph the system into really more of a security platform that is really focused on, helping our customers, implement things like microsegmentation strategies. Like I said, really shrinking their attack surfaces across multiple facets. And so when you interact with Secure Workload, first and foremost, it's important to understand there's really two modalities you can consume this platform as. One is as a service. So we have this offering in the cloud, right? Cisco powered cloud, and you can consume it as a kind of a traditional subscription service as you can with many other Cisco technologies. Or you can consume it as a hardened security appliance that would run in your traditional data center and keep all your data kind of localized in your data center, and kind of everything is yours, right? Rather than just having just data fed up into our secured cloud instances. And so that's kind of how you typically would consume Secure Workload. And there's kind of two pieces to it. You've got the platform itself, right? And I just mentioned those two modalities of the platform, but then you also need to get data into the platform. And first and foremost, the primary means that many of our customers get data into the system is through the use of software agents that you would install on your servers or on your workloads themselves. And like I mentioned, we have agents for all sorts of different shapes and sizes of systems. Again, VMs, bare metal boxes, container type deployments. We're in the future, we're already looking to integrate with like serverless, and even PaaS type architectures. But for now, it's going to be more of the traditional VMware, Red Hat, bare metal type of Windows, Linux kind of distributions. But we also have the ability to get data if an agent isn't possible, because we know sometimes it's just not possible to put an agent somewhere. We can also get data via kind of just traditional standard-based network collection methods. So we can integrate with, NetFlow and span exports for just getting network telemetry from network devices or maybe security appliances. We can also get data from application delivery controllers, like really popular ones like from F5 and Citrix, that comes up a lot. We can get data directly from both Cisco and non-Cisco network appliances and security appliances. And the purpose of that is just to have data available in the system so that we can kind of push, pull, and prod at the data and apply our kind of security use cases to it as best as we can. Agents do provide the richest data that we traditionally want, but we always will fall back to, essentially, as Nick said in the beginning, it really all starts with visibility, and we don't want to have black holes of visibility anywhere if possible. So whether that's going to be getting data from, network devices or from the servers themselves, but we even have integrations with Cisco ICE and, for example, Cisco AnyConnect clients, so that we can actually get data, more from the traditional enterprise campus environment and bring that in, or even from Meraki devices as an example, so we can get data from your wireless infrastructure, or even from firewalls. And so the idea is we want to get data in, we want to pull that in so that we can then turn around and give you the insightful information back to there. Where it starts is once you're logged into the UI, it's a web UI like I'm showing you here on the screen. And once you have data in the system, I'll show you how we get that in a moment. Once you have data in the system, you get all sorts of dashboards that kind of just light up with insightful information. And we're going to essentially, I'll give you a brief overview of kind of like our main dashboard that's simply trying to call attention to how you're doing as an overall security posture, right? We're going to score you across 6 key metric areas. The first is going to be your vulnerabilities. These would be software level vulnerabilities. We're going to score you based on your process hash scores, meaning, we're looking at what processes are running within, your workloads, and running threat analytics against that, those process hashes on the back end, and looking for obviously malicious intent in any of those processes, but also looking to see where variances exist between processes that might actually be benign, but there are some, slight variances between those benign processes. We look at your attack surface score, and this is a big one, right? Because a lot of our customers really gain value from our system, and in really just a couple of small steps, we can point out where like maybe 80% of your risk could be from the network standpoint, right? And a lot of times that's simply servers that are sitting out there, frankly, providing overexposure. Maybe there's TCP or maybe UDP ports that are just available and listening and ready for interaction, but they're not actually doing anything actively, right? They're just kind of out there. And in many cases, the way we score you, we're like, hey, if we see TCP or UDP connections just sitting there idle for like 15 days doing nothing, but they're still there, why don't we just close that stuff down, right? And we like to point that stuff out so that you can, whether it's you're using our solution to close those things down, or you're just manually going into those servers and closing down those connections. But just doing that as like a good general hygiene yields dividends as far as, being able to mitigate your attack surface. We also look at what we call a forensic score, and we're actually running threat intelligence and analytics behind the scenes to see how your servers are interacting within the server itself, like how applications are functioning inside the server, what they're doing, how they interact with other applications in your environment. And we run all sorts of both public and private, Cisco proprietary threat analytics against all that information to kind of come up and say, look, we see some suspicious behavior, or we're seeing all sorts of benign behavior, and you got nothing to worry about. So we have a forensic engine that we kind of run things through. That some of the stuff that we pull in externally comes from like Microsoft, from Red Hat, from Talos, from big names like Reversing Labs as well. But we also are looking at, kind of our own threat intelligence feeds to really, calculate what some of these scores mean. We look for network anomalies in your environment. So we're looking literally for how much traffic goes in which directions, between servers, across networks. And we look for just variances in, and a lot of this is just using, pretty complex mathematics to try to learn with, machine learning algorithms in place to figure out what is normal behavior versus abnormal behavior. And when we see that abnormal behavior, we like to call attention to it. And it could be something benign, but also could be something pretty malicious. And so we like to try to provide, that level of insight. And then last but not least, the last piece to this is going to be, segmentation scoring, which this is really big. And this is one of the biggest value pieces to what Secure Workload does. Secure Workload wants to help you implement microsegmentation at scale, right? And we're going to score you and provide these scores based on all sorts of criteria, like, how much of your traffic is conforming to your allow list, and how much of it is actually conforming to your deny list, which could be an actual problem, right? This system operates in a traditional default deny all rule base, meaning, we are enforcing kind of the zero trust mindset. So you need to go in and tell our system what policies do you want to explicitly allow, right? And then we'll let you know, hey, this is the traffic that conforms to your allow list. And then this is the stuff that's actually happening, if any, that is actually on your deny list. And if that's happening, that's a problem, right? This is where you see the segmentation score go way down, and we call attention to the fact that, hey, you've got some traffic happening on your network that should not be happening, right? And whatever controls are in place to prevent that traffic from happening are failing. And so therefore, that's kind of an alarm bell to take action. And so this dashboard that when you first log in, you kind of get your scores, and you can kind of see where you need to focus more of your attention on initially. Well, right now vulnerabilities are pretty high. 40, 100 is your best, 0 is your worst. So 40 is not good. We want to call attention to some of the vulnerabilities, and from the dashboard, you can just click into it and be like, oh, look, this server, which is a SQL server, it's running some old SQL code and it's got some vulnerabilities against it. And you can click into, kind of a hyperlink there, and you're able to kind of see that, hey, look, NIST is actually declaring this, to be X, Y, or Z, and now we need to go do something about it, if we can go do something about it at all. Maybe something that's like a simple patch, or maybe just informational letting you know, like, hey, until this gets fixed, this is a potential issue, right? And you can see the CVSS scores that are related to that. So you can kind of go down through the dashboard and kind of figure out where you need to focus your time and attention. Like I said earlier, the attack surface score can be really, really valuable, because it'll simply tell you like what servers are presenting overexposure, yet they're not needing, technically it doesn't appear that they need these network protocols open and listening, because these could potentially be places where bad guys can maybe interact with that server, and frankly, there's no need to do that. So that's the main dashboard. But to even get data into the system, right, so that this dashboard does stuff, what we want to typically do is get agents deployed. And so what we do on the left-hand side is how you do your main navigation with the platform. And under manage and under agents, you're able to essentially get the agent files from Secure Workload, right? You actually download the agents from the system. And we typically recommend the use of what we call our auto agent installer, which, it's kind of a simple wizard where you just, almost pretty much click next, but it's going to ask you, what do you want to put an agent on? Is it a Linux box? Is it a Windows box? And then it kind of self-explanatory just gives you some information, say, hey, look, these are all the different systems that we support. If you're doing a traditional agent, you click this button and it actually gives you the file that you would actually apply to your systems. In this case, for Windows, if you use our auto agent installer, it's going to give you a PowerShell script that you can then maybe hand off to your SCCM team or something like that, and they can apply this script to tens or hundreds or thousands of machines, all with this one file, and the system will go ahead and do its piece, and go ahead and provide the installation kind of in a silent, unattended manner. So once you've got that piece, you can go ahead and just click next again, and it's going to tell you, hey, look, this is the command to run for your pre-checks. This is the command to actually do the installation. If you're going to do this more in a manual fashion, it's going to give you all sorts of extra criteria to say, if you want to provide any extra flags or anything like that from an advanced install perspective. And when you're done here, it's going to say, hey, we're going to listen and look for those agents when they're deployed. We're going to kind of check in and check them all in and make sure everything is good. And so once you have those agents deployed, they'll show up in your agent list. All right. And what's neat about that is once you've got agents deployed, data will in fact actually start coming into the system. And obviously we love seeing that data coming in. You can actually kind of see the data that we immediately start collecting from the system right away. So I kind of clicked into one of those systems that have an agent on it, and you'll see all sorts of criteria that we're starting to monitor and kind of collect for. So the first thing is going to be labels. So this is a pretty powerful piece to our platform, which is you can apply labels manually, or you can also ingest labels from other systems automatically. And so, we'll cover that more here slightly in the demo a little bit later, but labels and, what the system has label-wise, that's here. You're able to see, how well the agent is performing. You're able to see how much resources that agent is consuming on that host, which we get this question a lot. And the answer is our agents, frankly, consume very, very little. That's by design. Now, the heavy lift and the really heavy compute happens on the platform itself. But our agent, the way it's been designed, it's designed to kind of be like a little ghost, on your server, and it collects network packet header metadata. It doesn't collect full packet payload, so it's really not heavy on the network wire. But it also, for what it does, it really just kind of collects inventory snapshots of your application, your processes, and stuff like that. So we're really not doing much on the system. We're sending these snapshots to the platform and letting the platform kind of use its analytics engines to post-process all of that. So the back-end stuff, really where the platform sits, is heavy, but the client side of things is very, very light. And we can obviously put SLAs to ensure that our clients are operating in a very, very light manner. But you can monitor that from the system, and you can, like I said, you can put SLAs so that agents can only do so much. But typically, we're using less than 1% CPU and generating less than 1% memory and network overhead by our agent, which is always within our customers' acceptable levels. As you can see, we'll pull in all the long-lived running processes running on that box. We actually map that process tree out on your systems, which is really nice. And so you can actually see how all the processes interact with each other. And we use this for our forensic purposes, right? So we take all these snapshots. We can actually show you how an application, from the kernel down on that operating system, how things interact with each other and what commands are being executed to create maybe a child process from a parent process. So we track all that. We track all the flow data coming off of all the various interfaces. We have all of the packages running. We have a full snapshot collection of all the different packages that are running on that server, whether that's Linux or Windows or container type host. We have it all there. We actually run threat analytics against it, so we can identify vulnerabilities maybe to a particular package, and you'll see them listed out here. Again, the agent's kind of categorizing all of this. All the stats that I mentioned, enforcement, right? So if you are managing policies with secure workload on this system, we frankly will be able to show you, for example, all of the policies that are actively enforced by our system, or any policies that may be present, presently existing on there. So in this case, we only have a couple of policies present that we're actively enforcing on this particular system. But what's nice is you have a central place where you can actually see all the microsegmentation rules that may be in place. Or you can identify that, hey, look, this server really has no security policies being managed locally on it. So this is definitely a system where we would want to then apply microsegmentation policies to. So that's kind of just a general overview of agents. But if you wanted to not use an agent, we have all sorts of connectors that we can pull data from, whether that's flow data. So we have like a AWS connector. We're going to soon have an Azure connector so that we can pull in like native VPC flow logs, so that we can get that network metadata into the system and begin to just start identifying what we want to do with all that data. We can pull in things like NetFlow and F5 and NetScaler kind of data. And this is great for our customers because there may always invariably be a place in your network or in your workload side of the house where you just can't put an agent. Maybe it's a really super obscure or maybe even old non-supported version of an operating system that you want to collect data from, or maybe like a mainframe type of application, and we don't have an agent for it. So these flow ingest methods that are more kind of traditionally network-based allow you to at least get the data from the network side of the house, and then we can then work, if you want to do microsegmentation with those architectures that where you can't put an agent, maybe we can turn around and push policy to these different devices, because some of these devices can actually receive policy, and whether it's macroseg policies or microseg policies. Secure Workload allows you to author policies in a very generic way, and then you can choose where you want to export those policies to. It could be something as simple as you want to just export a CSV file of all the policy ACLs that you've kind of written out, and you just want to consume those in maybe using a Python script to convert them to a native firewall format that you're using. Or we have some direct integrations with like Cisco Firepower, ASA, Citrix F5 type devices where we can natively push rules directly to those devices and use those devices to act as a kind of a perimeter protector of network traffic to these architectures that frankly, don't support an agent, meaning you can't push policies natively to those local, maybe Windows or Linux firewall mechanisms that are present on those operating systems. So you've got all these flow ingest methods of getting data into the system. We can get data from various endpoint architectures, like I mentioned before. AnyConnect and ICE are really popular, so we can get information from the campus and really understand what's happening at the workforce level. And then we can also pull in data, for example, from like ServiceNow, so we can get inventory enrichment. We can also pull in data from IPAM systems, so we can understand host names and DNS records and stuff like that. And obviously, if we want to integrate with external alerting mechanisms, we can do that as well, so that CSW, or secure workload, or formerly known as tetration, can really be part of your general security, SecOps practice, right? And making sure that our system, if we see something, we say something to the right system where the admins and the analysts are actually looking and providing security back to the business. So that's really all I wanted to go through about agents today. But again, once you have agents deployed, the data and all the dashboards, really start lighting up. And I kind of showed you one of the dashboards earlier. Now, before you really start using the product to do things like microsegmentation, one of the things that you need to do is what we call defining scopes. And defining scopes is really all about telling the system, how do you want to organize your environment in our system? So essentially, once you've got agents on systems, you're going to be collecting, tons of data, and there needs to be some, essentially organization applied to the chaos, which is all this data. So scopes will allow you to, frankly, go in and provide a, sorry, I keep getting these little pop-ups, but scopes allow you to provide organization to all the chaos that is all this kind of unregulated, unorganized data. And so what we do with scopes is we always have one root scope. I think of scopes almost like similar to like an Active Directory OU structure, right? Where you have a forest with, parent and child objects. You're going to have kind of your root scope where everything kind of falls in, and then you're going to define child scopes from that root scope. And so, for most of our customers, you're going to have at least a scope per application. So for every application you want to microsegment, you want to have a scope for that, so that you can kind of cleanly identify what servers belong to which kind of organizational unit. And so the idea here is, if I have an application, in my case, we have one called SIWAP, which runs as a kind of a simple web app DB kind of application in our lab. Well, SIWAP, has 8 servers in it, right? And it's these specific 8 servers, and these blue hyperlinks here kind of imply that we have agents running on SIWAP. And so what we want to do is we want to have a special call out for Active Directory, or not an Active Directory, but it's really just like an Active Directory OU, essentially to say, this is what SIWAP is, right? It's these 8 servers. Now, once we have scopes and we've applied some organization to the chaos that is, all this data coming in, right? What we can then do is we can go in, and under the segmentation dropdown, we can actually start building workspaces where we can define, microsegmentation style rules for all of these, workspace, or for all these kind of scopes that we built. So for SIWAP, for example, which is one scope in our larger scope tree, what I do is I say, hey, I want to create a workspace. And in this workspace, you have 2 options. You can allow Secure Workload to build your policies for you using machine learning algorithms to essentially look at all the data that the agents for those servers are generating over a particular given time. And over here, if you hit Start ADM Run, the system will allow you to choose how much data over a given time frame for the given workloads. Like, for example, if you want to go back and say, hey, I want to use a month's worth of data and allow CSW to build me policies using machine learning algorithms based on like a month's worth of data, you can do that. You can go back 6 months. You can even go back a year. If you only want a week, that's fine too. I get a question oftentimes from our customers, well, how much data does CSW need to build these policies? We need at minimum 6 hours worth of data. That's like the minimum data block that we want to work with. But we can work with up to a year's worth of data. And I always say, being that, the system itself really does have some roots in data analytics and machine learning, and specifically unsupervised machine learning. The more data you give our system, the more likely you are to have all the policies you could possibly want to ensure that you're providing all the possible allow rules that your applications need to function, right? Now, because this is using unsupervised machine learning, typically what that means is whatever policies the system will recommend to you, we want you guys to still validate that the policies we are recommending based on the observations that the system's providing. We want you to validate those, right? It's very possible that if there were any bad behaviors occurring in the applications during the analysis period, Secure Workload will recommend, just in how it works, it'll recommend like those behaviors continue to function because it saw that behavior occur. So it's really up to the human man in the middle to come in and say, hey, Secure Workload is recommending this policy, but it may be something that is inherently risky, right? It could be something like, for example, the system is saying, look, you need to allow telnet or maybe another unsecured network protocol between a couple of servers. And maybe somebody on the security team says, look, we don't want to be using telnet anymore. Can we replace that telnet policy with an SSH policy? Well, Secure Workload maybe had already seen SSH policy or SSH interaction, so it recommended an SSH policy, but because it also saw a telnet interaction, it recommended a telnet policy. So we always want to encourage our customers to look at the policies that the system will recommend. And the way we do that, once the system has already kind of run and provided its policy recommendation, it'll actually list them out for you as a traditional ACL list. So you hit that Start ADM Run button, and the system will actually go out and give you a list of ACLs. And it's you have the ability to kind of come in here and see it in a couple of different views, so you can kind of understand and more maybe easily see what these interactions mean. I'm going to zoom in here for you so you can kind of see a little bit better. But the idea is it's going to show external applications or external users trying to come into the system and where they're coming in. And as you see, it's kind of an interactive screen where you can click on and see, hey, look, we can see it, the IPAM DNS environment is talking to this application. It's doing so over UDP 53. We can see the users are coming in and they're being identified maybe by these addresses, and they're all coming in on port 80. Well, that's kind of inherently risky. Why is this application providing port 80 services out? This may be an opportunity where somebody says, hey, look, the system is recommending we continue to allow port 80, but can we make this 443? Can we make this maybe an authenticated type of connection? So this is, again, the human man in the middle should be looking at these recommendations and turning around and maybe providing their own recommendations. And you can go ahead and edit and author your policies. If you don't like this interaction, for example, you can just come into your access policy list and say, hey, I want to find where that port 80 interaction is. Well, here it is actually, okay? And I want to change that from, allow port 80, I can dump it, or I can at least add a 443 interaction here for now, and we can run that for now. And make sure that 443 is going to start doing what we want it to do, and then maybe we can retire port 80. But the idea here is the goal of this portion of the product is to fundamentally really teach you what your applications are doing. Again, it's teaching you by saying, look, we looked at all of these, essentially what are called conversations. These are all the unique interactions that your servers are having, and frankly, they are. We're turning those conversations into policies. Okay, we're kind of auto transcribing that for you. Again, if you want the system to do that, if you want to just create your own rules, either at the macro level or at the micro level, you can create your own rules, right? You have the ability to come in here and create an allow action or a deny type action between any group or any other group. There's no issue with doing that, right? You have the full functionality to kind of self-author policies, but most of our customers tell us, they're like, hey, Cisco, we need a solution like this because we don't know what our applications are doing. We look at our app development team for that kind of information, but our NetSec or security operators are always saying, look, by and large, are saying our applications teams can't really tell us exactly how their applications function. So let's use a system like Secure Workload to tell us what it's seeing happening on the network and convert that behavior set into policies. And by all means, our system is designed to do that, and it's designed to do that at scale. Like, this system is designed to take all of these policies and manage them at extreme scale. Like, I think we can manage up to 2 billion rules today, and we can actually push those rules down into the servers themselves. So if you come over to the enforcement tab, we can actually come over here and hit a button, and these policies that are written down can actually be pushed into the servers themselves. And how that happens is essentially our agent. If you have an agent on a server, our agent has the ability to interact with a native operating system. So if that's a Linux box, we have the ability to interact with IP tables and manage IP tables as kind of the authoritative enforcer of IP table orchestration. So if you push enforce policies and this is a Linux box, we'll auto convert those policies right here into the equivalent IP table format. Or if it's a Windows box, we will convert that list of policies into its equivalent, either Windows Advanced Firewall or Windows Filtering Platform, which we're actually seeing pretty broad adoption now with our customer base and consuming Windows Filtering Platform as a primary means to provide microsegmentation down into their Windows environment. And the cool thing here is that we're doing that centrally from one place. So you push enforce over here in our system, and those policies are auto enforced in that application. And it's really simple. I mean, you take those policies and you kind of go through here, and it'll say, hey, these are the rules we want to actually push down, and you kind of click next, accept and enforce. And within a few seconds, you'll see those policies that actually get enforced into that environment. And so I'm going to skip a tab over here in a second and show you, if you have a few different applications, what's nice is, in these different applications, for example, if I have a SharePoint application, there's a whole bunch of policies here that we have for SharePoint. It's a pretty complicated deployment, as you might expect, kind of almost like a plate of spaghetti with all the different policies. Traditionally speaking, this is really hard to manage this volume of policies, at the microsegmentation level for even one application, if you had to go and manually now implement policies, or even through, for example, like AD GPOs to manage all of these complex policies for those servers. But what's nice about our system is we can actually go in and enforce right here, right? You can see, like in this case, this SharePoint application is enforced, and I can go in if I like and show you here in a second. I'm going to actually click into one of those workloads, and because we're enforcing those policies, I can actually see that SharePoint has all of these policies already presently installed on it. Like that SharePoint box has all these rules presently installed, and CSW, Secure Workload, is managing and essentially automating these policies from this kind of central dashboard. And so you can do this at scale, right? All Linux, all Windows. We even have support for kind of container-based policies if you have a container-based microservices architecture. Typically, we'll work with something like Kubernetes to act as the management orchestration piece to all of that, and we'll kind of tell Kubernetes what to do, and Kubernetes will manage all of that on the container pods themselves. But the idea here is that we can actually go in and centrally manage all of those rules from one place. And again, that even applies to even rules that you're pushing out to, like, not just Windows and Linux. That might be rules that you're pushing down to application delivery controllers. That might be rules that you're pushing down into Cisco or maybe non-Cisco firewalls. This is kind of a centralized place where you can, create, manage, and fully author policies, but then also take that extra step to enforce those different rules. So this is, I know I went through it relatively quickly, but this portion of the product is extremely powerful, and frankly, the #1 use case why customers are adopting it today. They need to implement microsegmentation as part of their security controls, and they're looking at a solution like Secure Workload to frankly do that for them. So I'm going to just wrap this up really quick. I need to hand this over to my Duo friends so that they can do their piece, but I just want to show one last piece of the product, which is also very popular. It's under our Investigate, and it's called Forensics. So Forensics, very different than microsegmentation, but the idea with Forensics is that we have a built-in forensic engine in this product, and frankly, what it's going out and doing is, as the agents are providing all these insights into how the network flows are occurring and how the processes are interacting and all the software that's running in your environment, our forensic engine is working behind the scenes and working, nonstop 24/7 to look for bad behaviors. Now, what are bad behaviors? Well, those are behaviors that get defined by, security operators within Cisco, security operators in the industry. For example, MITRE, we kind of have an ingest feed from MITRE that simply says, what is, nefarious behavior at the signature level between two different processes. Well, they'll give us all that insight, and then we will go in and look for those kinds of behaviors. And if we find any of those behaviors, we will call attention to it. And so you can go into this dashboard and look for those behaviors. If they occur, typically what happens is you get alerts, right? And you kind of tune the system to alert for you. And so yeah, the idea here is, this is kind of like a bloodhound running in the network and simply looking for bad behaviors. And we have all sorts of different signatures that we go and look for. Some of the ones that are really powerful that we look for, especially looking for kind of 0-day style behaviors, are these things that we call unseen commands. And, for example, like, we've never seen the SQL dumper.exe command executed before. And as you can see, we can kind of follow the process tree, and we can look for, things that are, potentially nefarious. Maybe it's benign, but we want to call attention to it, and we can simply click on it and see, like, hey, what was this thing that occurred? When did it happen? On what system did it happen on, right? We have a process ID here, which means we can actually trace this process ID to an actual network flow. And we can now use that network flow in our flow search engine to traverse the network and see, where did that thing start from, at exactly what time, and what are all the servers that process ID traversed on. We can see that, this is tied to a very specific process path. But the cool thing about it is, every time something new occurs in the system, and again, using machine learning, we figure out what we've seen before, and if it's benign, we don't call attention to it anymore. But if things continually happen, and they kind of take this, unseen command path, then what will happen is we'll keep kind of alerting you and saying, hey, look, we're following this process. This doesn't look right. We want to call attention to it. And this is just one of many, many examples where you could say, hey, look, these are all sort of examples of things that, we would want a security analyst to kind of follow this and mark it as benign. If they're not concerned about it, then the system stops, worrying about it. But if it's maybe something more than being benign, this could be the start of the next, type of exploit in your environment. So this is really just more of a forensic backend analytics engine that's running. I just wanted to mention that briefly. I know just a few minutes over time, so I'm going to probably wrap it up here. And I think we're going to hold off any potential questions to the end. So with that, I think I'm going to hand it over to Jim. I guess you're taking it over from here to start on the Duo side. Is that correct?
Yep. Thanks, Mike. Let me share screen. Good morning, everyone, as we approach the afternoon on the East Coast. My name is Jim Salmonson. I'm a technical solutions architect with Duo. Just going to give you a brief overview on how we align to the Zero Trust Maturity Model for identity and device. I'm going to jump right in and try to give you as quick as an overview as I can. But just remember that Zero Trust is a journey. It's not the destination. From CISA's Zero Trust Maturity Model, it's stated right in there, the path to Zero Trust is an incremental process. Might take us years in some cases. So something to be wary of in the back of your mind. If you think about Wordle, it's incremental. We get chances. Obviously, if we fail, we have a new day tomorrow. But something that was brought to my attention recently was Duo try Girdle. You get 37 chances to figure out 32 words. So little trivia for today. And if you have time later, jump on it. Please don't jump on Wordle right now. Hopefully have some information that might be beneficial to you. So we align to the two pillars of CISO's Zero Trust Maturity Model, identity and device. It's Duo's main feature here is validating the user, validating the device that's connecting with some base fundamental specifications on trusting that device before you allow it to connect to any application. 5 phases of maturity from a Duo perspective on how we support that. First phase is obviously getting strong authentication in. That includes MFA to verify the user before you allow it to connect. The second phase of that, our path is gaining visibility to those devices and their activity. So we are collecting information off basic authentication without an agent, surrounding the operating system, the browser, if it's browser-based authentication, or with an agent, we can collect additional information and surround the hardening of that device. Maturity phase 3, we want to apply a policy to control access. Essentially, if you think about how many applications you might engage on a daily basis while you're working, that is your behavior, and that is something that can be tracked and a pattern identified where we could potentially take that type of behavior and apply policies on it where if that behavior changes, you change location, you change computer, you reach out to applications you don't normally connect with. Phase 4, inspecting those devices, clearly making sure that whether it's a BYOD device or corporate managed device, we want to make sure we are getting visibility to that before you allow them to connect. And obviously phase 5 is zero trust, where we are having full visibility on the user, the device, their behavior, the policies that we've applied to them, whether they're static or dynamic, to make sure that we are securing the applications they're consuming. Duo offers flexible phish-resistant methods. 3 points there is we want to make sure we're streamlining the user experience, not adding additional friction unnecessarily to how they engage their applications. Obviously, we have a diverse workforce. By offering multiple ways to provide MFA, that addresses that, whether it's the privilege a user needs access to, whether they're accessing one application or the whole enterprise as a privileged manager, as well as supporting some ADA capabilities with some of our disabled employees. But the big point here is securing a hybrid workforce. When we are dealing with addressing our employees that are on-prem, off-prem, mobile, we want to make sure that we provide capabilities that we are providing that strong phish-resistant methods of authentication to get into their applications. I'm going to cover real quick 2 slides here. This is alignment with CISA's table in the draft. From an authentication perspective, we can provide an advanced level with MFA options. From an identity store perspective, we are able to align to advanced with on-prem, hybrid, and fully cloud environments. From a risk assessment, we can police users to make a decision whether we allow or deny access or point them in the right direction to get access. From a visibility and analytics, we can report risk-based changes in the user behavior by creating a fingerprint of what those users are doing on a normal basis. Supporting automation and orchestration at advanced level, we can integrate with multiple IDPs, as well as pulling information out from the history of the authentication process to support your SIMs and SOAR systems. From a governance perspective, we can automate tasks with SOARs and automate identity management processes. Getting into device maturity, we support compliance monitoring by validating device access at each authentication. For a data access perspective, we're protecting that front door with strong authentication with MFA. From an asset management perspective, validating those devices are trusted before we allow them to connect. Visibility and analytics, advanced centralizing inventories of devices validated during the authentication. So remember, each time a user authenticates with dual MFA on the back end, we are creating a report that will support your inventory of who is using, what they're using, when they're using, where they're using it from. Automation and orchestration, again, we're validating app access during authentication events, so we're collecting identity and device information. And from a governance perspective, we can validate, approve modern devices and block legacy devices. So in the demo, I'm gonna walk you through quickly through the MFA options, but I want to point out the visibility we gain for device posturing to apply policy and get a good look on the dashboard in the time we have. So I'm looking at my timer. I've got about 20 minutes. I'm going to dig right in. So from an authentication perspective, I know we have a lot of federal agencies that are using PIV and are expanding PIV. PIV isn't going anywhere. So where Duo sits, we are second to primary authentication. So whether you're applying PIV as your multi-factor authentication, or from a human perspective, PIV people might leave their cards at home and drive to the office, or they leave their cards at the office and they're at home. So the idea here is whether you leave your PIV card behind or you have new employees and suppliers joining the organization that have not been issued a PIV card, we can supplement those use cases. So from this perspective, somebody logging into the Microsoft Azure environment, they sign in with a PIV card. I have a certificate installed on my system to demonstrate this, and they gain access through their PIV. So cert-based authentication, allowing them to get in with primary authentication. What I've added on to this was the use of a security key. So what the security key is going to allow me to do is provide that phish-proof MFA capability to gain access with a PIV card. In the absence of a PIV card, of course, the user may have to default to username and password, where then we add the MFA event behind that. So what that will give you is the capability to add a variety of those MFA options. What I'm authenticating into is Duo single sign-on environment. And what I want to show you here real quick are we have options. So from a security key perspective, inserting a key in, answering that question, something you have, the Duo push app. If you're not familiar with, I can show you that on the side. If you reach out to Duo or me directly, we can do Duo OTP. Less secure methods of telephony and SMS are still supported in our commercial tenant. And we also provide account recovery. So if you leave your phone or your token and your PIV card somewhere you need to gain access, we can always do validation of who you are, either in person or over a phone, with whatever processes you have for identity verification to provide temporary codes to gain access when you leave everything at home. So from a Duo for security key, let me touch my key. That gives me access to the application. So what does that look like behind the scenes? So from behind the scenes perspective, this is the Duo dashboard. So remember, Duo is a SaaS service. And what you're seeing from an authentication perspective is what we've collected, timestamp, whether we allowed or denied access to the username, the application they're logging into. The Duo Central is the Duo SSO portal. And we collect some information about how they authenticated. So this is generic web-based authentication. We've collected the browser information. We've collected the location by geolocating the IP, at least to give you that base information, and we've got the operating system. So from there, without an agent, we can do basic policing on, are we going to allow Windows versus Mac to gain access to our applications? So from a BYOD perspective, a lot of our suppliers prefer Apple computers. A lot of our policies are no, we are a Windows environment only. And then shifting over to the authentication method, we document how they are doing that authentication from an MFA perspective. So this is kind of the baseline of where we can define an adaptive policy to whether we want to apply static policy or we want adaptive policy based on the user's role, group membership, or the applications they're logging into. So the visibility we gain from that and control is where can we limit access for least privilege, falls in line with the maturity model, but also how can we continue to support our end users to gain access to what they need access to in a hybrid workforce. So from a policy perspective, what this allows us to do, and we can build this around each application that we're protecting, whether it's a Windows login, Azure login, O365 login, on-prem, ServiceNow, or any other type of SaaS or on-prem application. Whether it's surrounding the user, building out policy on where they're allowed to enroll, so we can limit their enrollment to, say, on-prem while they're onboarding with the organization. So they cannot enroll outside of your organization. Having an authentication policy to enforce 2FA in addition to, if it's PIV or username or password, or if you have a policy you want to set, well, we trust PIV and we're not going to let anyone into an application without PIV. We can apply a policy that will bypass 2FA for those PIV users, but still collect their endpoint information. So what's going on with the device to say, well, you have your PIV, but your computer's out of date by a year. So we're not going to let you in and point that user in a direction to remediate. Obviously, user location, building out protections against states that are threats to us. Device, from a device perspective, whether it's trusted or not, gaining visibility with an agent. So with an agent, we are able to collect hardening status of that device in addition to the operating system. So is the operating system up to date? Is it hardened with a password to log in? Is file encryption turned on? Is the firewall turned on? In addition to that, we can link to your endpoint protection software. So is that software installed and running? So if any of those things become a policy decision maker for allowing to connect or not, we can control that access to say, no, your operating system's out of date. You need to update before we allow you to connect to this application. Or something has happened to your endpoint protection software. We're not going to let you to connect until that is remediated, and providing messages to the user as they're authenticating to point them in the right direction to authenticate. We also provide some of that granular control around the operating system. So if it's not up to date to a specific version, you can nudge the user to say, all right, and in 10 days, you will no longer have access to this application. You need to remediate. So that gives your user visibility that they are out of compliance from an operating system perspective, and then pointing them in the direction whether they need to connect to VPN, go into the office to get their software patches, or where we're seeing a trend in some of the suppliers at DoD where they're allowing the users to update some of the software, operating system, or browser information on their own. I think Apple just released an update that they're going to start updating the security patches to their operating system without a full operating system update. So we're seeing a trend in the industry where that is shifting. We're going to see more capability, whether it's not connected to endpoint management services for some of these basic security patches. So hopefully we see that move into the federal space at some point. And this also extends into the mobile device. So if somebody's accessing from a tablet or a smartphone, we can put some of these controls around that as well to make sure folks aren't logging in from an iPhone 4, making sure we're keeping things current for supported operating systems and devices. In addition to that, we're heading into a path where can we take all this information and make it useful, whether you're ingesting it to your SIEM to support a SOAR or direct support to a SOAR. So what we're able to collect off of this is that device information, and right up front, we can see we have systems in the organizations that are out of date from an operating system perspective. What that'll allow you to do, I'm going to go to my parent dashboard, which shows all of my lab to give you better numbers. So when you think about the thousands of devices that some of these large organizations support, and thousands of users, having visibility into what's going on with them, and where you can automate ingesting that into your on-prem SOAR systems, your on-prem SOC analyst systems, this will give you that capability, and we support that. So right up front, red light, green light, it's great to know what's going on with the authentication, who's getting denied, but to be able to look at what's going on in the organization and create meaningful reports where you can export that, where someone can take action that's of value. When someone's logging in, we're okay because they're complying with policy. But when someone is failing, whether it's a user mistake or the user is a potential risk to the organization or an active threat, attempting to log in from China, that's not authorized, we get that visibility during that authentication flow. So what that gives us from a device perspective here is we can quickly look at end-of-life systems that are actively allowed and authenticating into the network and your applications. We can identify out-of-date systems that fall below a policy set on the operating system or browser. And obviously we can see the green light there where we can see what is accessing it, and that is good to connect. So what this allows you to do, you can drill in instantly. Since we've collected that type of information, we can see who's logging in, where they're logging in from, their operating system, and timestamps. So this helps streamline that research to why do we have people still logging into this application with a Windows 8 device. From a risk perspective, down to 7 minutes, I'm going to try to cover this fairly quickly. Where we're heading is from a creating that behavior report of your users. So what this will allow us to do, and where we're going to take it in the future, is applying some automation to this, is we can see that from a user perspective, when they are falling into risky behavior, this user denied access from China, and the IP that they're accessing from is the trigger that they are doing something that they normally do not do. Obviously, we denied access, but what this allows us to do is mark this as suspicious behavior today. Obviously, we're looking at historical artifacts of what the user has been doing, but what this will allow us to do is create policy or to allow us to investigate behavior of a user if something were to happen. So right now, we live in a world of cybersecurity where in a lot of cases, we have to react to what happened in the history, so we can take steps to modify our policy and put in controls where we can limit those types of risky behaviors. Where we're heading as an organization, Duo is going to apply some automation to this in the future, dare I say AI, where when things like this occur, we can step up security controls around that user, whether it's denying them access, or at some point we can say, you know, we validated who you are. You validated that you have a multi-factor device that is strong and phish resistant, for instance, having a token or biometrics. Then what we're going to do is, okay, it looks like you're attempting to authenticate into an application that you have not accessed ever, first time accessing. So we're going to step up your authentication, and we're going to require you to validate that and add an additional control, whether it be a validated code that they may have to insert into the application as a response, or potentially using a registered biometric, whether fingerprint, Windows Hello with facial recognition, or some sort like that, where we can process that in addition to. So what that allows us to do is continue to ward off the bad guys, and then continue to give access to the users where they need it. To close up, I think I covered identity, I covered device. The future where we're going is going to be passwordless. So when you look at with the portal, the Duo SSO portal I logged into gives you access to different applications. So the idea here is that as we weed out the use cases of having a username and a password where we're able to register our device and register ourselves, whether it be biometric, PIV card, or other, where we're taking that is where we'll be able to centralize from a SAML perspective, whether it's on-prem or in the cloud, where your users will be able to use a biometric. And essentially what that'll do is if they have to do their primary authentication, whether it's PIV up front, beginning of the day, that'll allow them to be able to use some of those biometric capabilities for passwordless or using those tokens where they're able to authenticate without a password. And this is a drive where Duo is heading. So we'll continue to be able to provide strong authentication against your users to support them with phish resistant. And I'll say a lot of folks say we've implemented MFA, so we're secure, but the reality is we still need to review where we're going with MFA. If MFA is ever compromised, you still want to review those logs and look for any historical patterns where behavior of a user might give us an idea that we may have a compromised account or potential insider threat to the organization. So with that, I am going to kick it back to Peter and close out if we have any questions or concerns. But my name's Jim, I'm with Duo, and I support MFA and device for workforce protections.
Thank you, Jim. So I'm Peter Romness with Cisco. I'm the cybersecurity principal in our CTO office. Thanks for everybody for joining. I hope you saw that there is no single thing that gets you to zero trust, but we have many things to help you get there, and we've highlighted 2 of those today. If anybody has any questions, please reach out. We will be dropping some after documents into the ATARC notice, and so you'll have those. And with that, thank you everybody for joining, and have a great weekend.